Hello, in this first engineering dialogue, I am going to give you a brief introduction to kinematics of machine. Kinematics. Kinematics is a branch of classical mechanics that describe the motion of points, bodies, and systems of bodies without considering the mass of each of the forces that causes the motion. So masses and forces are totally neglected in kinematics. What exactly a kinematic problem looks like? A kinematic problem begins with describing the geometry of system and declaring initial conditions such as position, velocity, and acceleration of points within the system. Using these arguments, that is the initial condition, position, velocity, and acceleration, the geometry, position, velocity, and acceleration of unknown parts of the system can be determined. Why study kinematics? Kinematics in mechanical engineering is used to describe motion of systems composed of multi-link systems. In astrophysics, it is used to describe the motion of celestial bodies and collection of such bodies, because it deals with motion. Father of kinematics. It all began with a German scientist called Franz Rühlich, who gave the definition of machine. According to Franz Rühlich, a machine is a combination of resistant bodies so arranged that by means of that machine, mechanical forces of nature can be compelled to do work, accompanied by certain determinate motion. So the motions of a machines are determinate and mechanical forces of nature are compelled to do work. So this is an arrangement of resistant body called a Boulton-Watt steam engine, in which the mechanical forces of nature, that is the steam energy, is converted into mechanical energy. What is a mechanism then? According to Franz Rühlich, mechanism is an assemblage of resistant body connected by movable joints to form close kinematic chain with one link fixed and having the purpose of transforming motion. So a mechanism is again an assemblage of resistant body connected by movable joints, but here the joints are connected so that a close loop or chain is formed and one link is fixed, which forms the frame reference for the other. The purpose is to transform motion. Here is an example. A translatory motion of this piston slider crank mechanism piston is converted into rotary motion of this crank over here. In this problem, the initial forces and masses are neglected, and this becomes a kinematic problem. You can see that this is the crank and this is the arrangement of the piston cylinder. So there is a sliding pair over here, and the forces and masses are neglected, so it becomes a kinematic problem. This is called as the kinematic diagram. What is structure then? Structure is an assemblage of number of resistant bodies without any relative motion between its parts, which are required to take up forces. So structure is only meant to take up forces. There is no relative motion between the various links. As you can see over here, this bridge is designed to take up forces. So what is the meaning of all these terms that we discussed now? There is a direct analogy between the terms machine, mechanism, and structure. Structure in which the links or the resistant body don't have any relative motion, just meant to take up forces. So it deals with the mechanical branch or the mechanics branch of statics, while mechanism is meant to deal with only consideration of motion, hence it comes under kinematics. Machine on a whole covers the dynamics, the initial forces, and the masses also. So it comes under my dynamics as a whole because it deals with power, torque, etc. So this is the analogy between the various terms discussed here. Thank you.